Welcome back, everybody, to the Science Metaverse podcast. It has been a while since our last episode in February of 2023. It is July of 2025 today. There's a lot that's happened since February of 23. With me here is my co-host, Steve.
Hey, everyone. Been a while, but Science Metaverse is still kicking strong.
As well as a new Nanome team member here with us.
How's it going?
And so, just a little bit of a recap on the Nanome side. Since late 2023, we actually launched a new product called Mara. Now, the story behind Mara is actually quite interesting. We've actually been a long believer. We've always wanted to build the Jarvis for molecules. And so one of the early hits of early kind of features that got a lot of traction back in the day was voice commands back in when we actually supported the Windows PC VR and we actually leveraged the Microsoft Cortana API. And, it was kind of like the Alexa of molecular and computational chemistry, where you can just do some kind of basic stuff. Change the surface color, load certain molecules, things like that. But our scientists loved it, and they really wanted us to build on further into it. Unfortunately, though, the Cortana API got deprecated. I believe it was like 2020, 2021 or something like that. And so we wanted to continue building on it, but we also didn't want to build our own voice recognition system. So our CTO, Sam, as you might remember, who appeared on multiple episodes before, mentioned, hey, there's this thing called, back in the day, it was called natural language processing, NLP. But also LLMs, large language models, were on the up and up. And so, he came to us in like late 22, early 23 and said, I think the time is now to integrate the latest technologies and latest advancements in NLP and LLMs. And that basically, the spiritual successor to voice commands was Mara. But the more we kind of went down the rabbit hole of integrating LLMs, we actually found out that that's just it's a complete game changer. And there's much more than what you can do beyond replacing voice commands. So anyways, that's a little bit of an intro of Mara. But Steve, did you want to kind of talk about Mara, what it does?
Yeah, it's been a long time coming, right? We've always wanted to, have this Jarvis-like assistant in the program with you, helping you pull up molecules, run simulations, change things like coloring. And the reality is that, that was changing things like coloring, pretty limited with what we had with the Cortana API. And using voice commands in order to kind of change things in the VR workspace. And the combination of AI technology really taking off and it being practical to use it to do a variety of tasks now with agentic frameworks and the Cortana API being deprecated, it really was just the right time for us to be doing it, as well as expanding a bit outside of the VR XR exclusivity and getting people to be able to interact with the general platform outside of XR, but always be able to go back into XR and really do the heavy lifting of the analysis, the collaboration, things that really benefit from being in the XR environment with the headset on.
Yeah, so since the beta launch in February of 23, we've been adding a bunch of different types of functionality to it. But at the very basics, right? There's all these different foundational models, whether that's obviously the OpenAI models, Meta's open source Llama, of course, Google is coming up with Gemini. And so, we're fairly agnostic to whichever one scientist wants to use, of course, Claude as well. And so, but there's all these, different computational chemistry tools, algorithms, packages that are available out there that comp chemists are already used to using. And so, what Mara is the ability to kind of connect using large language models to talk naturally to those existing computational chemistry algorithms and packages, so that people who may not be used to command line interfaces can now naturally talk to these super powerful packages that are already out there.
Even if they are used to command line interfaces, which aren't really too hard to navigate, and sometimes it could be kind of quicker if you've already got everything set up. But really, like, the breadth of how many new things are being released from open source academic papers and different companies putting things out. So there's just so many tools in the back end. So how do you make a better interface to connect and utilize and spin up those tools? And I hear this from people in industry, academia, just different hobbyists. People want to do the cool calculations that give them a lot of good results. And not a lot of people really want to take the time to set everything up properly, run it all properly. So having AI do the heavy lifting and having a tool like Mara really helping you out, I think is a game changer because of everything it gives people access to.
Yeah, I mean, originally, like I'm a bench scientist, so I did my work in a lab, in a fume hood, in a glove box. But I also started to dabble in computational chemistry, and I could write the scripts to do the things that I needed, but remembering what all of my arguments were and having to go back into that script to then find out what I needed, the information that I needed, where it was, change little things. It was, it takes time. That's why that's somebody's job, and you can't just moonlight as a computational chemist and expect to like increase your output. But when you can have all of your tools inside Mara and all of these processes be variables, and you can just use natural language and have Mara pick out which part of your sentence goes in as a variable and which files it needs to grab and in which order it needs to do them, then you don't need to take all of your Python scripts and, meticulously order them with another Python script that calls them all in order. You just ask Mara to do this for you, and it will put a workflow together for you super easily.
Yeah, and speaking of workflows, one of the amazing things with Mara that we've done fairly recently, that's more on the late 24, early 25 update of Mara, is this ability for Mara to basically create a pretty easy to understand GUI, graphical user interface, of a workflow that you made using natural language. So, if you say, hey, look, download this PDB, take out the ligand, calculate these properties, it'll essentially come up with a workflow and confirm with you, hey, here's what I'm about to do. These are the tools that I'm about to use. And you can easily drag and drop those, the steps in different orders, customize them further using natural language. I mean, this is a really powerful platform to further orchestrate your computational workflow. So we're really excited about how far Mara has come. But it's not just Mara. In 2024, late 2024, we finally were able to launch Nanome version 2. Now, we might have talked about this in previous episodes, but Nanome version 2 is a big step for us, coming from, the last version of version 1 was version 1.24. And we basically learned a ton of lessons, like V1 was meant for PC VR. It was, built for really VR instead of MR. It was built for these touch controllers that came out in 2016, 2017. And now we have these like extremely high resolution mixed reality interfaces. Augmented reality devices are coming out. And controllers are no longer needed, right? Especially with things like the Apple Vision Pro, where you can literally look and pinch super naturally and easily. And so it's not just that; it's also obviously a much more robust backend when it comes to scientific data management, and reading files in, parsing them properly, things like that. Also, lots of lessons learned on that end as well. And so Nanome version 2 represents a complete rewrite of our entire code base. And we're really proud that we've been able to launch that towards the end of last year with early access. And really, Nanome version 2 and Mara are meant to go together, right? Mara is the virtual assistant for Nanome, and together they make the Nanome AI suite. And so that's kind of a quick recap of what's been happening with Nanome over the last just over 2 years, I guess, from February 2023.
I mean, there's a lot of things that we learned from developing and talking with customers, and we tried to implement everything as best we could. But I think that when you have a product really built for a nation industry that's just emerging, you have the 2012 like Kickstarter with Oculus, you have the developer kits, you have PCVR consumer version Rift 1, HTC Vive. It was a different era. I mean, it was like 10 years ago when all these headsets really started becoming consumer ready. And it wasn't until 5 years ago that we even got like promising standalone headsets. And now I think it's pretty clear the direction is, really great standalone headset experience with a lot of things in the cloud doing the heavy lifting. So this really ties in with, AI, Mara, the agentic architecture to pull data from databases, run simulations on your behalf. But what is the future? I think the future is going to be wider, lighter, more wireless. You're going to have, glasses, AR glasses. This is kind of the holy grail that everybody wants to see. So yeah, right now it's standalones, and I think that building everything for standalones is really the same architecture that's going to be very future proof, whether they're a PC VR user, standalone VR MR user, or a future like AR type of standalone headset user as well. This is the platform.
I guess on that note, Steve, about future devices, a couple of things that we haven't recapped. A lot of things have happened since February 23, including Apple's announcement of the Apple Vision Pro that happened in June of 2023, and a subsequent launch in, I think it was like February of 24. And also, Meta has launched the Meta Quest 3S as well. Oh, wait, Quest 3 was in, Quest 3 was in 23. Quest 3S was in 24.
Yeah.
And as of today, you can actually get a Quest 3S for $250.
Good deal.
Which is a really solid deal. But I know, Joe,
I like my Quest 3 a bit more, but the Quest 3S, I think for $250, that's a great headset.
I mean, I totally agree. When I started using VR for research in 2017, I had to be wired to a PC, and everyone, if we wanted to meet in the same room, had to bring their laptop with them with their giant cables, and we even had base stations. So like we had a room, the national laboratory I was at, that had 4 different base stations set up, so we could have an expanded space that we would be in, but we were still tethered to laptops that were put all the way around the room so that we could all meet together in a space. And now we have, MetaQuest 3s that we're mainly using. It has augmented reality, so we could literally all sit around a table and put a molecule on a table and have a conversation, and still we don't need avatars to express body language. We can literally look at somebody and see the body language they're expressing as they're describing the molecule they're talking about.
Joe, I think that's an excellent transition to an introduction about yourself, and you mentioned getting into VR in 2017. I guess if you want to talk a little bit about your background, how you got into research, and how you got into VR, and then go from there.
Yeah, definitely. So I started, my background would be, I have a PhD in biochemistry. Mainly what I was doing is artificial metalloenzyme design. So inorganic synthesis with protein expression, protein design, and everything in between, from molecular biology to spectroscopy. Whatever I needed to do, I did those tasks, and all of it was either in a fume hood, or a lot of my work was anaerobic based, so super oxygen sensitive compounds. So everything was in a glove box. And to get into VR, this is when I was designing artificial metalloenzymes, and my goal, I was doing a postdoc at the Pacific Northwest National Laboratory, and they had oxygen sensitive compounds that they were basically like, you need to put whatever compound you want in a protein. We don't care, just pick one. And the protein, just pick one. They were studying how amino acids affected the catalytic rates, catalytic efficiency, all the things with catalysis, and what impact amino acids had on those. But generally, it was 1 to 2 amino acids around a metal, and not like a full-on protein environment. And my goal was to bring the biochemistry side of what an actual protein environment, what that impact has upon catalysis. So it was any program or any protein that I wanted, any complex I wanted. But even with all that freedom, that's still super hard. Like, when you're designing a small molecule, you can draw that all in ChemDraw. And if you're designing a protein, you just have the protein that you're designing and you're mutating. but how do you accurately understand what all your bond lengths and angles are and what that distance of a molecule is once it's, relaxed? And all of these things have motion and they're not a static 2D image. So trying to have confidence that the small molecules I was going to make were going to fit in the pocket that I wanted and actually have the interactions that I was shooting for with that protein scaffold was an incredibly hard task. And I actually was told to stop working on the project because it wasn't going anywhere because it was really hard. And I refused to give up, and then I eventually got it. We got a crystal structure, and then from there, my project continued for another 3.5 years. But if it wasn't for VR, I wouldn't have made that project work. So it's like I love VR for research. It did make my project work. So
it's an
lots of
awesome story. I
positivity
mean,
there.
PhDs are hard, right? But when they're telling you to pivot your research because it's too hard, it's kind of silly because, right, it's like you're supposed to be working on this extremely hard area that you want to like crack the new knowledge of and publish and share that with the world. So the fact that you're able to do that by utilizing immersive technology, virtual reality, getting in there with your protein structures, it's awesome. So
Yeah, I mean,
keep it up.
synthetically it was super hard as well too, but like that, there were a few things. It wasn't just VR. It was also realizing that the synthetic route we were taking was not the right route. Even though published, it should have worked. It was one of those things where you have to like prove that a publication isn't, just because someone published it doesn't mean that it's going to work for us in our lab and our conditions. So that was part of it too. But
Classic
yeah,
reproducibility problem.
yeah, all the fun of breaking new boundaries.
So, Joe, a couple of things. I know that back then, you were using UnityMole. If you could talk a little bit about, how you found UnityMole, how you ended up working with some developers behind UnityMole, and then go from there as well.
Yeah, definitely. So one of the meetings, before anything had worked, I was showing an image of the protein we were going after. The protein's called LMRR. In nature, this protein binds to DNA, and if you remove 2 lysines per chain, then it stops binding to DNA. So from there, this protein has lots of work done with it as well too. So we weren't the only group using it, but it has a very defined pocket at this homodimeric interface, and there's 2 methionines that you can move and mutate to cysteines. And so I was trying to show the image where you could see those cysteines prominently there in the center, but I was also measuring 2 distances, and in my image that I was showing, a short distance looked longer than so here in this image, the one up front to the bottom left, that line looks longer than the line on the top middle that looks shorter. And really the one that looks short is twice as long as the one up front. But I wasn't trying to convey, in that image distances. I measured them. I measured them in PyMol, just great software for looking at your 3D molecules in a 2D plane. But I made a terrible image for one. I'll admit that. But then what it led to was that a room full of PhDs were arguing whether or not PyMol can measure a distance, where the automatic answer is yes, PyMol 100% accurately measures distances. But I made a terrible image. And then everyone got stuck on what those distances were, and we spent a half an hour arguing a point that nobody should have been arguing because I made a terrible image. And at the end of everybody going back and forth, I was like, look, if I could just put you in VR, if we all could be in the protein, nobody would be arguing with me. And that 15 minutes, 30 minutes of us going back and forth would have never happened. And it would have just been like, look at this distance, we're in the pocket, let's move on. But I had actually tried to make VR programs before as well too, and I didn't have access to VR. Like I could make augmented things on my iPhone, but I couldn't make a VR one. So I was also like, but I've tried that, it's hard, you can't do it. And my boss at the time just kind of laughed and was like, "Oh, we have VR. We have Unity Mole. We have a whole lab." And I was like, "Are you serious? Like, give it to me. Give it to me, please." So they did. So like a week later, I had my own like VR laptop, and I had an HTC Vive at that point, and they were like, "Here, like, world's your oyster. Do whatever you want." And that's when I met Xavier. Xavier is one of our developers here at Nano. Like, great guy. Like, him and I used to meet like his evening, my mornings, and he would help me with my terrible attempts at coding and show me what I needed to do to get the result that I wanted. And
Before ChatGPT was there to help you out, right?
exactly, yes, I had Xavier before, and way better than ChatGPT. I wish ChatGPT could do what Xavier did for me. So it was great, but it was really cool because he was working on a postdoc as well. He was trying to make Unimol as great as it could be, and we got some papers out. Like, one of the papers we have was moving APBS into VR. So you could do super high level electrostatic calculations. You could show field lines, really cool things that we were able to do that people have cited. So it's been really cool. It was also awesome to come here to Nanome and be like, "Hey, I know you. Like, this is awesome. This is fun." So it's cool when the small scientific community you see your friends over and over.
Joe, I know you didn't talk about this a little bit, but I guess how did you get into VR in the first place? Was it like Beat Saber? Was there a certain VR game that really hooked you in?
I mean, literally, it was Unity Mole, man. Like, once I got hooked on being able to like literally be in a molecule, then I bought myself a PC VR for home, and like literally, I probably shouldn't say this, but I definitely did not take my desktop PC VR computer home from the lab and back and forth on a few weekends. So like that was, but and then they ended up giving me like a laptop that I would take home from there. So I had multiple VR computers that the lab gave me to develop these things. And yeah, I mean, part of it too was like I was also part of the visual analytics group there, and like one of my mentors from there was like, please play games, like play all the games ever that exist and figure out what kind of UI works, figure out what kind of like menu system works, and like see what other people are doing to try to understand how, when you're developing for Unity Mole, what you should be doing and what you shouldn't be doing. But yeah, we had, Beat Saber, the kids and I love that game. Arizona Sunshine was one of my favorites. But there's this game.
Got to represent Arizona.
It's yeah, of course, right? There's Acron. I think it's called Acron. It's these games where the person in VR is a tree, and then everyone can join on their phones, and they're squirrels, and they try to steal like the acorns from the tree, and it's a really fun way to get like multiple people into that virtual space without everyone needing a headset as well too.
And there weren't too many VR games in that era, so you could actually like play all of them and try to
Yeah,
pull the
right.
best UI UX. Yeah, the Acron one's pretty interesting because it's kind of similar to like how you might have a person presenting in Nanome with VR and then having a bunch of people joining in like 2D mode.
Yeah,
But obviously, it's a gamified aspect of that. But I think that that's like a really cool way to design applications in general, because like not everyone's going to be going into VR or have enough headsets. Like you mentioned, having your kids or a bunch of people playing with you, but only having one headset. So I think that there's a lot of really great ways to work with each other where everyone has a headset, but thinking about ways to get people without headsets to also partake and enjoy and be in that collaborative experience, I think is awesome.
yeah. I mean, with V2, we're building a window into VR from your computer, whether you're on a Linux, Mac, or your cell phone, right? Like, it doesn't matter. You always have a portal into that virtual space that someone's in, which is something that like when I was going to conferences and doing presentations or even like a poster, like how can I put somebody in my protein environment it there. Like when 2017, this wasn't a thing you could do. You would have to like bring an entire rig with you. But now, like a Quest, I can hand somebody a Quest and put them in there, and they're not even isolated anymore.
You can easily
They can be
carry
in be in
3 or 4 of
pass-through.
them, right?
Yeah,
And hand them out to people. Everyone hops in there together. Yeah.
yeah, yeah. It's definitely great where all this is going.
Yeah.
So, when you first joined, I guess a quick fun fact about Joe is that in I think it was like June or so of 2024, we actually put out we did a email blast to our user base and a email list asking who wanted to join our team, and Joe was actually one of our applicants from that. So I guess how did you hear about Nanome? What were your impressions about I guess V1 back in the day? What was that like?
Yeah, I mean, fun story for me is like I found your GitHub, like one of your first GitHubs, but it was publicly available, and I downloaded that and thought it was super cool. Like you guys had an ability to draw molecules that was different than what exists now, and that was really cool because I tried to build that on my own as well, and was like, this is like it blew my mind drawing a molecule in a 3-dimensional space. That was really cool. And then
Steve, I think that's
yeah,
Nano One.
Well, yeah, we had Nano One, which was kind of like the OG molecule builder with like carbons, maybe a couple
Yeah.
other. But then yeah, we re-implemented in Nanome, 1.0, and had the sort of the panel where you could pick all of your different molecules and atoms, and then you're making these bonds that are too long, and it's minimizing for you. Felt very really I guess like natural, very fluid when you were building, as opposed to like click click click, and it's just kind of doing all this in 2D, and you're not really getting the full 3-dimensional understanding as you're building it.
yeah, and it was that 3-dimensional that I wanted, because for me to be able to get my small molecules into VR, like, because again, bench scientist, right? Like computational folks, they're like, yeah, this is easy. I could do that in 10 minutes. But like, I don't know what programs to use at that point. So I would take like a ChemDraw 2D, and then I would move that into Avogadro, and then I would minimize that. But then like I'm using rhodium bis diphosphenes, so I'd have really weird bond angles. And then like, how do I fix those? And it was all so many like small things that took me so much longer than it should. Now knowing like how to do that. But if I could have literally just like what I can do with V1, I can draw my molecule in a 3-dimensional space. I can select certain parts of it, move them in 3-dimensional space, and minimize as well too. I could have done what took me like weeks to get in a few hours in Nanome now. So it is really cool to understand like how you actually can build a molecule in a pocket and how much time that actually saves.
Sorry, Joe. So you were saying you found our GitHub. You downloaded probably Nano One back in the day, and that's how you found out about us and got on our newsletter list.
Yeah, pretty much. Like started. Well, it wasn't Nanome then, right? So I think I had to put together that like because that GitHub also disappeared at one point. So then like I went back for it and was like, oh no, like what happened? So then I've been following you guys since I mean a really long time. So it's been
I mean, if that was our original like Nano One GitHub with Nano VR, like that was the beginning. Yeah.
yeah. So yeah, there you go. Been following you since the beginning. And yeah, it's been really cool to see what comes and what goes and different avatars coming in and things like that. So it's been and now, I get to help, guide the train a little bit. So it's pretty fun in that aspect.
So I guess you didn't really get to do a super deep dive into V1 until you actually joined us.
Yeah, like I had used it. I had done trials and things.
Yeah.
But never like when I was at the national lab, I had developer access to UnityMole. So if I wanted something, I would just put it into UnityMole. And then from there, I went to some startups that I had shown them, like, hey, look, VR exists for protein design. Like, this is super cool. But we were like 4 people, and they were like, we can't, I'm not going to buy you a headset. I was like, but I have my own. Like, all you need is this. And they're like, make us millions first, and then we'll buy you VR. So but at home, I was still doing the same things. I would go home, use my personal VR to do the research that I needed because I found so much value in that.
So I guess what were your, now looking back, I guess about a year ago since you joined, how was, you know, diving deep into V1 like?
I mean, it was the things that I wanted. Like I wanted to be able to minimize, I wanted to be able to draw. I could load electrostatic potentials. I mean, I have my own PCVR, so it was nice to be able to like load big molecules and do that. But having basically like unlimited access to all the tools that we had, like that was great. Like I've always felt like the fact that this is a job for me is awesome. Like I get to, for me, like I love proteins. I love that environment. I love making things that didn't exist and being able to just have unlimited access to a virtual space to do that is like a kid in a candy store. And then I get to help other customers do that as well too. So it's a different thing every single day and a different problem every single day, and it's just really really cool for me.
So, the reason why I wanted to ask you about V1 was because, obviously you've been predominantly working with V2 over the past, I guess half a year or so since we've launched V2. And, today we just had a huge new update to V2 with version 2.2. But, I guess talk a little bit about that, how you've seen the evolution from V1 to V2. I know I've heard you say that you can't go back to V1 anymore, so would love to hear a little bit more about, things like that.
Yeah, and I mean, as great as I'm making V1 sound, like V2 is just so much better in every way. Like one of the things with V1, there's present like only one person can be a presenter at a time, and only one person can grab the protein and rotate it at a time. So then if you want a different perspective, you have to physically move around the room, or you have to move your avatar around the room, which then means you have to break your concentration on what you are looking at. So for me, the best part about version 2 is that every single person at any point in time can have whatever perspective they want without wanting to move. Like I remember the very first time that I tried V2, Sheila, like our product manager, was like, "Hey," once we were done, she asked if I ever felt like I wanted to move, like stand up and look, and I was like, "No, actually, no, I did not." That's weird because with V1, I always wanted to try to do that, or there was an avatar in my way, or something, that broke my concentration. And in V2, you never have that. We do have the ability to spotlight, so one person can have everyone follow their perspective or one person follow their perspective, which is great because sometimes you want everyone to focus on what needs to be talked about. But I mean, a protein environment it's a big thing. There are different residues, there's different angles, there's different pockets, there's different surfaces, there's different color schemes that you might want to look at to get different information. And the ability to just seamlessly go through all of that is really like, again, it's great. Like it's great that this is something that I get to help people use. That I mean that you guys have built for people as well too. Like it's a great platform.
Everyone in Nanome is building this, right? We have a really awesome team, including Xavier, who used to be, working on Unity Mole when he was doing his PhD. And I feel like over the years, you two included, Joe, we've been able to like assemble the perfect team for doing what we're doing. People that are passionate about bringing molecules into your hands and making them immersive and making them things that we get this intuition for. I've talked about this a lot, right? Like, how do you build intuition for something that's smaller than you could ever see? It's not a scale that we're familiar with. It's not things that are around us. It's not something you pick up, grab, look at. You can't even look at it under a regular microscope. You got to do some really advanced characterization with X-ray diffraction, electron microscopes to even try to resolve anything at that scale. And then once you do, it's a digital file. And the great thing about digital files is that you could render them, display them in a variety of ways, share them with people around the world over the internet. And so, the fact that you're part of this team helping build that and put all the pieces together to to make this reality true, especially with the AI edition. Yeah, like we're on the path that we set out, and I feel like we're making some really great progress, both team building, product development, kind of getting everything put together to really build the ultimate interface for science.
Yeah, definitely. Just great team. Like it has been awesome to find people who are all interested in, something that we all love. Like how do you help people understand what they're building? Like some chemists are great. They can in their mind, they can draw something in 2D and they understand what they're building, what that looks like, that three-dimensional space. But not everyone in that meeting shares that same view, that same mental image of,
And you can't
which
share that. It's impossible.
yeah,
It's not like, hey, let me just download the thing
yeah,
from my mind to your mind. Like there's no, it's not real
Come on,
unless it's
Neuralink. No, I'm
shareable.
kidding.
yeah.
Well, not honestly. If Neuralink came and they like, I could think something and then it's like transferred as a digital file and then like reconstituted in your Neuralink, sure,
No,
like
here's my SD file.
that makes it real.
Yeah.
But for right now, it's
Yeah.
not real. It's like it's just in your head. It's made up. You have this hallucination. This is the human hallucination of your molecule in your head, and you can't share it with anyone unless you turn it into a real digital object and go into a real digital environment like VR and show it to people.
Yeah, but I mean, with Nanome now, you can literally just grab a molecule and hand it to somebody
Yeah.
and be like, "This is the torsion I was talking about. It was this interaction here. Highlight it. You can measure those distances now. You can show those chemical interactions. It's really great."
So speaking of measuring those distances, with this update that we're releasing as of today, of the day of we're recording here on July 9th, 2025, we have version 2.2 coming out with the debut of our first 3D interaction tool in version 2, which is the measurement tool. Joe, is this full circle for you? Since your beginning of the journey of the measurement tool, like.
Yeah, I mean, our software is supposed to help people design molecules, whether that is a small molecule, whether it is a drug target, an enzyme, a protein environment, and distance is important. Like, where can I build a hydrogen bond? How much space do I have to fill? Like, can I put an N-methyl group here? All of these things generally would be output as distances to a computational chemist. And then you would have a meeting. You would wait a week for your computational chemist to get your data at the next meeting, right? And now you can just literally hop into the molecule with your computational chemist and instantly measure those distances and then understand what space you have to build with. So literally every meeting we can cut out a week of time of people waiting. And that is awesome. But also too, full circle, like you said, being able to like measure that distance and literally just grab and click, point and click, and then you're done. And you don't have to, like, one of the hardest parts about working with a three-dimensional object on a flat screen computer is that you're working in 3 dimensions on a 2-dimensional space. So trying to get that perfect rotation so that the atom you want is directly in view, and then hope that when you click, it doesn't unselect what you just did is, I mean, it can be done when people are experts at this. It's great. They set it up to begin with, they do their thing. But as new users come in, it's not always intuitive as how do I grab that atom? Like, what special selection option do I need to be able to grab that atom? Whereas literally when you're in Nanome, you just point and, you touch it, you click, you touch it, you click, and then you have your distance.
Yeah, it's pretty funny how indoctrinated we are to like these abstraction interfaces where you have this 2D plane of a mouse, you're clicking on things on a 2D screen that you're seeing, you don't have a really good depth perception. So if you click on something, it's essentially just like this straight line where like anything in that line would be clicked on. But in VR, you have this point precision in 3D space. We're able to just reach out and grab. And it's funny because some people, when they go into VR for the first time, they're like, okay, I haven't played video games. Like, I'm not sure if I know how to interact with this. And we all know how to interact with things in 3D. It's the messy 2D interfaces that we've had to adapt to, that we kind of take as the paradigm for how we should interact with things, that throw us off. Because I think that you should interact with three-dimensional things in a 3D way. It makes sense, right?
Yeah, no, totally agree. I mean, we're research with molecular things. They're three-dimensional objects, and I mean that's also one of the things I do love about like what PC VR enables. Well, hopefully we can bring nicely to standalone, but PC VR at the moment enables molecular dynamics in virtual reality. And proteins, enzymes, they have motion, like they do their jobs because they move. And being able to watch that motion in a virtual space and see what residue may come in contact, because before doing this in a virtual space, again, you have a two-dimensional plot that shows distance versus time, and you get like a little square thing, and you calculate how often that atom may be close to the atom of interest. But being able to measure a distance, watch that update in real time, and find the specific pose that may be advantageous, like that, it's another level that it's just more helpful than a 2D plot.
Joe, if you had to name top 3 things off the top of your head that you're looking forward to with version 2 or Mara, I know sharing workflows is one of them, but any other top 3 things that come to mind that you're looking forward to with V2?
So not just sharing workflows, but what I like, science inherently is a collaborative thing. Not one person gets anything anywhere. People publish papers, people read those papers, and then they advance upon that. So the real advantage I see of sharing workflows is once I have a workflow, I can share it and make it public. Other people can share that workflow and make it public as well. And to some point, I'm hoping that this can get to some sort of standardization of how people do things. The next thing in V2 that would be great would be, when we're able to draw molecules in V2. And after that, I would go with what's next? I don't know. All the things, man. I think I don't know how much I'm supposed to let out, but so I'm just gonna go with this
I'm
one
just
because I
saying,
want it.
anything you
Yeah.
personally want. Exactly. Yeah.
I want we've talked about it as, so I want to be able to, and I think that would be amazing.
I'm just gonna.
We're not supposed to talk about that one, Joe. You gotta keep
Yeah,
that.
I know.
one.
That's why I was saying I'm gonna say the one we're not supposed to.
No, I'm just gonna
we'll get
beep out most of that, because the
Yeah.
back end stuff is secret sauce. But we'll just say, MD simulations and V2, for right in general. Steve, what about you? What are your top 3?
Oh man, it's already got a lot of things that I like. But yeah, definitely building. And I'd say beyond just small molecule building, being able to, put together like protein structures and get, funky with the three-dimensional like Lego molecule Legos type of aspect of it. I think that's going to be really fun. Then again, I'm a nano engineer, and I've always kind of wanted that. This was Nano 1. This is why we built it, so we can get hands on and start building things with atoms and molecules. So yeah, I'd say that's probably my number one thing I'm looking forward to, in addition to just like the ubiquity of access. Like I mentioned earlier, not everyone has access to VR headset, or if some people do and they want to share it with other people that don't want to put on the headset, like how do you make that collaboration more seamless? So, people being able to join through web, or at least being able to access and set things up through web. In addition to interacting with VR, we've already made big strides there with the web page where you could access your workspaces and change your representations, as well as using Mara to do the same, as well as calculations. So I think we're on a good track there. But yeah, in-app Jarvis is probably the big one that we haven't really talked about too much. Right now you have our assistant Mara, which is like our Jarvis. On the web, you chat with it. You could use your phone, voice to text and all that type of stuff. But inherently, it's not in the VR system with you unless maybe you're on Apple Vision Pro and you pull up the web browser next to the molecules, and you kind of have the two applications running side by side. But yeah, full on Jarvis that's there helping you pull things up, context aware. You say, what is that? And it's like, that's lysine 35. And you're like, change it to an arginine, and it like just does it. So you could have voice commands, eye-based context, so it knows what you're looking at. Hand tracking based contacts, so it knows what you're pointing at. Just becoming fully integrated with AI and XR, because right now it's a baby step, and you got to get the baby steps done first in order to be sprinting. But yeah, I'm really excited for that full on like scientific sprinting with smarter AI, because AI is going to get smarter, every year. And having a wide variety of access to tools, you become the bottleneck. It's literally an interface bottleneck to be able to understand that data more rapidly, tell the AI what you want to do next, and understand just the science behind it. So you kind of need to have the constant understanding as a scientist of what's going on. And if you lose that because we're using so many different AI tools and we kind of lose the context of the full awareness, I don't think that we're really going to be getting the results that we want to achieve. That people are talking about AI breakthroughs and all this stuff. I think that you need to get some coherency in there by having the scientists fully engaged and fully aware. And so, yeah, as AI grows and it becomes super powerful, able to do all this cool stuff, way more than it could do today, we need to empower the people.
Wow, that was like, I think I would say, perfect ending, and we could probably wrap up, but I haven't gone yet. So I want to go, which is I agree. Like if you didn't mention it, I was like, yeah, Jarvis. Cause like that's number one is like native voice input with Mara interaction, like within the XR application. I can't wait for that. Second, which I don't think any of you mentioned, is co-located, or as Apple is calling it, shared spatial experiences. I just want to, in my opinion, what we're missing in order to put on a headset onto somebody at a conference and be like, check this protein out, is co-located, right? Like, so then that way, to me, this also eliminates, what we experience a lot as nanomers, which is like, we need to be seeing what the person who is getting demoed sees, so that we can ensure a smooth experience for them. But with co-located, when you can say, look, here's the arginine, or this is the ligand I'm talking about, and you can literally point to it, and you're also in the headset together, I think that's going to be an amazing thing, and I think our users are gonna love it as well. And then lastly, I think somewhat of a small feature, but also I think can't be understated enough, is hand tracking support. We have partial hand tracking support with our Apple Vision Pro application, where you could do the eye tracking base, but we don't have that yet for Quest. And unfortunately, a lot of people associate the Quest controllers, with the gaming controllers, just because they happen to have the joystick and the A, B, X, Y buttons, although they're much closer to just actually gloves, I would say. But nonetheless, there's that stigma, and I also think, frankly, it's really nice because these stupid controllers are battery drainers. The gone are the days of the Quest 2 when they would last forever of the battery. But with the Quest 3, they just you one day you put in a full battery, and the next day it's like, oh, by the way, you got to put in a new battery, and you're like, what?
I used to be really big on rechargeable batteries, like for just generally like the CV1 controllers and stuff like that. I was like, yeah, rechargeable is great, because like you're always going to be recycling them. But then in the Quest 1, Quest 2, I got really into the non-reusable, so that it just lasted forever. And I was like, dude, I could put this one battery in and it's going to last like so long. And so I kept that going with the Quest 3, and I've gone through just so many disposable batteries that it's terrible. And so I've gone back to using rechargeable batteries.
Yep. And so, because they run out of batteries so quick, I've luckily I have the habit of carrying extra batteries in my backpack, but I would be in a pinch if I didn't have those batteries, unless we had hand tracking, where I could just be like, you know what? No batteries, no problem. Put this headset on and bam, use your hands, right? So I personally can't wait for that.
I mean,
Well, also,
we
I
have it
mean,
on
think
AVP,
about
right? Just
Yeah.
yeah. I mean, when you're bringing headsets somewhere, if I have 4 headsets with me, that's 8 controllers, and that's that. Why not just bring a 5th with no controllers? And I would, bring more things. So
Yep. Yep. Well, awesome. Thanks everyone for your awesome insights and great conversation. I think that was an awesome episode to for us to come back after February of 2023 of a kind of a current state of Nanome, and also introducing our newest team member Joe to our audience as well. So really awesome to have you all, and we'll see you in the next episode.
thanks, everyone. We'll see you in the Science Metaverse.
Steve said it.
thank you.
Steve said it.
I said the thing.